Hi, I'm David. Welcome to PRO-TEC Advanced Welding Solutions. Thanks for tuning in. Today we're covering the PRO-TEC 100S setup and operation, and we'll be stick and TIG welding very shortly. First of all, quick overview on the specification. This machine, 100 amp welding output. Input voltage is 120 volt input and has the ability to run on both a 15 amp and a 20 amp circuit. That means it'll run on standard on any home domestic outlet. Process capability is both stick and DC lift TIG process for welding. It's also very small, lightweight, portable, less than 10 pounds, great little system. So what we're going to do is set this up and in just a moment, but first of all let me just talk you through on the front panel a few things on the setup. First of all, power switch is on the back. If we turn that on, you'll see the main power light will come on. Next light here with the thermometer is simply a thermal overload protection. If you would see duty cycle on the machine, it will put itself in a safe mode and not to deteriorate the internal components. It will shut down in the thermal overload mode. Our switch here is for our two processes. So switch to the right is a picture there of a stick welding handpiece. Switch to the left and we have TIG welding handpiece. This main control knob is our main current output. So the higher we go here, the higher our amperage output on our welding terminals. And this goes up to the 100 amp maximum. One really important thing I want to show you here is there's two little positions with a couple of little marks listed here. One is at that point there, and what that is actually is if you were running on a 15 amp circuit, that is the maximum point you can run for stick electrode welding. If you run any higher than that on a 15 amp circuit, it's a high likelihood that you'll trip the breaker. As long as you don't exceed that point. And that point there, if you were TIG welding, same. So there's settings for both 15 amp and then 20 amp, you can do maximum output on the system. So, if we were going to set up now for stick welding, which we are, the first thing we do is grab our electrode handpiece, 25mm DIMS connector, and we want to make sure that we are plugged into the positive terminal, which is the terminal on the right side there. Turn that, nip it up so it's tight, and our return lead and clamp we plug into the negative terminal for stick welding, and we're going to be welding with some 3/32 electrodes that we got from Home Depot. And we're going to run here at about, let's say, 70 amps. So I'm right on the maximum there I should be on a 15 amp circuit. Okay, we're ready for stick welding. Quick look at the front panel. Selection toggle here is on stick process. We're on the positive terminal for our electrode lead and the negative terminal for our return lead. I've dialed up 70 amps, so I'm right on the maximum on a 15 amp circuit, and I'm running a 3/32 2.4mm 6013 general purpose electrode. So away we go. Remember, when we're striking the arc, a lot of people tap down like this, no good, chip the flux off and it'll stick to the plate. You need to strike it like you strike a match, and you'll find it'll start much easier. Very smooth, stable, nice soft arc, no spatter, very easy self-releasing slag, like so. And nice clean weld bead there. So one of the other little tips I want to show you is restriking an electrode, and depends on the type of electrode. General purpose I find to restrike, if you had a low hydrogen type 7018 electrode, generally not recommended for restrike use, but for a GP like this it's fine. But what I want you to see is, in fact, when you stop welding and use half an electrode, you have the core wire of the electrodes burnt up in the inside, and you have this outer cone around the electrode. Now the problem is, when we try and restrike, that's an insulated material there, and it's not going to conduct for welding. So a lot of people struggle with that. So the tip, put your thumb over the top and just break that slag shell around the top of the electrode off, so you're exposing the core wire. Not too much, you don't want to chip the flux right off, but just so you've got exposed metal at the tip there, and then you'll see here we'll restrike much easier and continue with our welding. Okay, so we're now changing over to TIG weld. The output's DC, lift TIG operation. So we flick the switch across to TIG. We've connected our TIG torch here to the negative terminal opposite to your electrode terminal. And return lead now is plugged into the positive to our job. Also connected regulator to a cylinder of 100% argon, and we're set up here with the torch straight to the cylinder through the regulator. On the torch itself there's a valve. We must make sure we turn the valve on, which allows our shielding gas to come through, and when we finish welding, make sure we turn it off, otherwise we're going to empty the cylinder of gas. Okay, so we turn that on. I'm welding here, I'm just doing straight fusion, so it's easy. With this type of joint design you can see it very simply in operation. Very smooth, very stable process, and a lot of finesse required for TIG welding. I'm running about 55 amps for this application here. Now, lots of people hold the TIG torch different ways. My preference is to hold it like this. For this sort of application, you need a very steady hand, and just make sure you're comfortable with the setup. For arc starting, what we need to do here is not tap the tungsten like we would with a stick electrode, or strike like a stick electrode. The best way is to actually touch the ceramic outer nozzle on the job, because that's insulated, and then just lift the torch up, touch the tungsten onto the job. You'll feel it stick and then break, and away we go. So when this starts, because the machine has lift TIG, what that means is when we're actually touching the tungsten on the job, it's at a very reduced current output, so it can break away and it will quickly ramp up to the 55 amps that we've got set on the dial. Okay? So you see there, no spatter, no slag, beautiful, clean, tiny little dinky weld bead on top of that edge of the weld plate there. And the way I started, touch, break away, and then move along, following the weld pool along the top edge of that plate. If I wanted to use filler material, I could, just like an oxy-fusion process, similar, except we've got an electrically generated arc, where I would manually add filler metal in to add more deposition and build up the weld pool in a bigger way. But for this sort of application, you really don't need to do that. Okay, so there's TIG welding. DC, lift TIG. Make sure the turner shielding gas off, and away we go. Well, that wraps up our PRO-TEC 100S stick TIG system setup and operation. This is a great value package suitable for light fabrication and repair maintenance work, and it's the perfect starter package for the weekend warrior, ready to weld right out of the box with all the accessories included. Built for safety, performance and value. Thanks for tuning in. See you next time.